In this video, we have a position function, and we want to look at it in a bunch of different representations, and then calculate the distance and displacement. Our first task is to come up with a tabular representation for every second between 0 and 5. That's just evaluating the position function at the various times. So at t is equal to 0, we're at 10 meters. At 1 second, so 10 minus 3, that's 7 meters. At 2 seconds, that's going to be 10 minus 6, that's 4 meters. And we're seeing we're going down 3 meters each time. So at 3 seconds, it's 1 meter. At 4 seconds, it's negative 2 meters. And at 5 seconds, it's negative 5 meters. Next is a schematic representation where I have a coordinate system with positive x going off to the right and negative x going off to the left. I have tick marks indicating every 2 meters. So it starts at 10 and then it goes down to 7. So I see this particle that's essentially moving at negative 2, then negative 5 at 3 meters every second. Now I want to draw the vectors that represent each position. At t is equal to 0, this position function is a vector function of time. And so it actually represents this vector with a magnitude 10 and pointing in the positive x direction. At 1 second, it's this vector, magnitude 7, same direction. At 2 seconds, this vector, magnitude 4, positive. 3 seconds, we have a magnitude 1, positive. Now at 4 seconds, we've changed direction. So now we have a magnitude of 2 pointing in the negative x direction. And then finally, we have a vector with magnitude 5 that points along the negative x-axis. Next up is a graphical representation. I may have squished my axis a little bit here, but I think it'll work. At 0, we have 10, and at 1, 7 seconds. 2 is 4, 3 is 1, then 4 is negative 2, and 5 is negative 5. So we have a straight line, as we knew we would, given the function, and now we have a graph of the position. Finally, we want the distance and displacement. The distance is the total length traveled, which is 15 meters. The displacement, though, is the final position minus the initial position. The final position is 5 minus the initial position, which was 10, so the displacement is in fact negative 15 meters. Remember, the distance is a scalar, that's the total length, but the displacement is a vector. So the displacement is a vector of magnitude 15 meters and pointing in the negative x direction.